off, I think we just always conflate privacy because it just seems so intuitive. So I wanted each one of you to actually try and define what you consider to be private, what the core definition is, and how contingent it is on metadata and different linkability that could affect core privacy.
Okay, so I'll start. To me, privacy is control over your information. So privacy is a way to keep information about myself either known only to myself or being able to tell it to somebody of my choice. So that is perfect privacy and sovereignty over the information and not letting anybody else get data on me. Now, in terms of different technologies, anonymity sets, and trade-offs in privacy, I think with all the tech that is out there, we can't be naive and think that there is such a thing as perfect privacy, because it all depends on the amount of resources somebody wants to put into disclosing some information about someone. So achieving a total privacy of, or very good privacy of your financials may be very good with a private currency against a casual attacker or a some blanket surveillance, but it may be very hard or impossible against like a nation-state actor or a large corporation trying specifically to attack or get information about a person.
Thank you. I would mostly agree with everything that Alex said. I would say that the fact that there isn't a way to define privacy perfectly is quite fine. I think that privacy as a definition pertains to whatever the context is. So privacy is about defining exactly what you want to reveal and what you don't want to reveal. And privacy also has to do with interactions. So if you keep your information to yourself and you never want to use it in any kind of interaction, then privacy is, trivial. Privacy, just keep your information to yourself. So in the context of transacting with other people, then the question is, if you're going to engage in the world and be able to use your information to, say, send financial transactions to someone else, then how much do you fundamentally have to reveal? You're obviously revealing something. You're revealing something to the other party, for example, maybe who you're engaging with. It's all about being able to define what your privacy goals are and then use technology like cryptography in order to meet those goals.
I'm gonna repeat some of it. I think the definition of privacy from an international perspective is pretty obvious. No one should learn more about me than what I'm willing to share. I think where it gets really hard is whenever you're trying to do something that's non-trivial, as Ben is saying, and you're trying to build an interesting systems, then it becomes a really, really hard problem to solve. And in that case, in many situations, you would actually find like maybe smaller definitions of privacy or specific definitions of privacy that you can live with. I mean, for example, in transactional privacy, often you split it into confidentiality and anonymity, right? These are two properties that both of them are kind of under the umbrella of privacy. But the reason we do it is because getting like that intuitive notion of privacy is like really, really hard.
So I think we're really lucky today because we have, usually when people talk about privacy, they're either talking about ZKPs or specific privacy coins. And I think right now we have on stage 3 very different privacy techniques: Mimblewimble with Beam, Zero Knowledge Proof with Fedora, and multi-party computation that Enigma is building. So I would ask if each of you can give a short description of what you chose, the trade-offs and the reasoning behind those trade-offs, and how further down in the ecosystem that could, the ramifications of that choice and trade-offs.
Okay, so Mimblewimble is a relatively new protocol that allows very good privacy, and what it achieves, so it's probably not as private as ZK Snarks, which is probably today the gold standard, but it has much better scalability. So it's one trade-off here. It's another trade-off for Mimblewimble. It actually achieves privacy by making all transactions interactive. So it's another kind of downside of Mimblewimble, which we at Beam have overcome in terms of user experience. But still, it's a limitation that, unlike any or most of other cryptocurrencies, you need the two parties to cooperate to build a transaction. The initial trade-off was very good privacy and much better scalability than any other privacy solution. We're actually now looking into other optional solutions and technologies that we will add, such as Lelantis, for example, that we will add to our blockchain to increase the privacy even more, again, with a certain trade-off of scalability, and the users will be able to choose.
Okay, so at Findora, we are, again, like using techniques that I think there's a lot of similarities in the underlying techniques between different systems. And so it's hard to say that a whole monolithic protocol like Mimblewimble or Zcash or Bitcoin confidential transactions are really extraordinarily distinct. A lot of these systems use common underlying techniques. So in Findora, in particular, we support both as a basic. What we chose to use are both the ability to do basic confidential transactions in the Bitcoin style that hide the amounts but not the transaction graph, as well as Zcash style transactions. We chose not to go with the Mimblewimble optimizations to Bitcoin confidential transactions because we didn't want there's downsides of having to have interactive payments, so it's nice to be able to pay someone without requiring the interaction of the other person who you're paying, as well as the fact that in something like Mimblewimble, the transaction graph is still almost being revealed, right? So if you want to have anonymity, then really the best thing, at least in my view, is to use something that is more similar to Zcash. In terms of scalability, reducing the amount of information or other things like that, you can solve those in ways that are using other techniques that reduce the amount of information that needs to be stored on the ledger that is kind of orthogonal to privacy, such as using accumulators, which we're using as well.
So Guy, we have these two guys who are basically building their own protocol, and you guys chose multi-party computation on top of Ethereum. So if you can talk a bit whether or not privacy has mandatory needs to be as a base layer, or is it okay to build as a layer 2 privacy solutions, and how Enigma has tackled that question?
I mean, first of all, I think, if in one of the layers, I don't think you can actually disconnect these. Like, if in one of the layers you have privacy issues and that network is public, then that's where people are going to derive their data from, and then they're going to use that data and correlate it. So whenever you have, in any type of security system or privacy preserving system, whenever you have a weak, whatever the weakest link is, that's what people are going to come after. So I don't really think we can have like privacy just on the base layer. I don't think we can have it just on the second layer. I think we need to have them on both, maybe to varying degrees and in different ways. In terms of, what was the second question? How are we tackling it, like compared to?
How are you tackling the difficulty of basically building a second layer privacy, and how much of the linkability and the leakage, how much does it affect the applications that are already being built on top of Enigma on your testnet?
So, I mean, first of all, what Enigma cares about is really more of a more generalized notion in the sense of how can we get privacy in smart contracts, any smart contracts, and we really care about making this as simple as possible for people to build on that. But there is a transactional aspect of it, right? Like, because Enigma is a second layer right now, so everything that happens on Enigma, except some metadata that happens on Enigma, everything that happens there is private by the way that it works. But the way Enigma works is it allows you to actually develop kind of like a mixed model, smart contracts. So public parts work on Ethereum, private parts work on Enigma. So for example, if you want to do some voting scheme, then the actual votes would be sent encrypted to Enigma. The tally would happen encrypted on Enigma, but the results themselves would be committed back to Ethereum and revealed there. So that's one aspect. But the problem is that often when you make that reveal on the public chain, which is public, that's usually where you gotta be careful, because if you're not, then you can actually, that could create privacy issues. The other aspect is transactional privacy. Everything, Enigma is still an ERC20 token. Gas is still being paid in Ethereum. So all of that metadata coming from basically running computation, sending computation, doing that kind of stuff, all of that is completely public. There are ways to mitigate it with mixers and other technologies. They're not quite as perfect as what these guys are working on, but it's probably the best we can get right now on Ethereum. But yes, that's exactly why I think that both layers need to have privacy.
So now we're talking about privacy. The other part of privacy is, of course, that the minute we say we're too private, everyone freaks out, i.e. the regulators. And then there is the attempt and the promise of making all these different techniques work for the regulators and serve as a compliance technique for auditability. And I was wondering how each one of you has been focusing on it. And let's remember, everything that's being said here, the first zero-knowledge proof-based application is basically Zcash, and it's only about 3 years old. So I think we're still in the early days of trying to figure out how we can marry the two worlds of compliance. And I'd like all of you to share your experiences.
Any regulators in the room here?
No, we kicked them out.
Okay, good. No. I think the technology is moving forward very fast, and there's no way to stop it. So the technology will allow people to be more and more private, whether the regulators want it or not. But at least our vision is that the new technology, the new world of crypto, does not need to destroy everything and replace all the financial system, but for the foreseeable future, it will need to coexist. And in order to coexist with the ecosystem, you have to be able to disclose some information to some people, right? You don't have to disclose all your information to everyone, as it more or less happens today with Bitcoin, Ethereum, and a lot of other open currencies. You have to have your privacy, but you have to find a way to be able to disclose if you want to. So the model we want to build is similar to, in some respects, to cash, right? If I have my shackle bills, I can spend them without identifying myself and without leaving any trace. But on the other hand, the coffee shop or the bar that receives my bills usually has to issue a receipt and then has to bring the money to the bank in the end of the day or month or whatever, and have it documented. So the system we want to build something we call opt-in auditability, where each actor will choose whether they want to leave a trail or not. And if they do, then this trail will still be encrypted. They would be able to show it to the tax person or to the bank if they choose so. So I think the solution is to combine the two, let people choose whether they want to be private in full or not.
So Ben, you guys, I think, have taken it another couple of steps,
Right.
and I will confess, I'm a big fan of how they're working with compliance. If you could speak about that.
Yeah, absolutely. This is, as Maya said, really the focus of our work, and I wouldn't view privacy or even compliance as two binary options, where either you can remain private or you can choose to leave an audit trail. I would also look at compliance as extending far beyond regulators, and look at the ways that actual users in the system want to enforce certain policies on transactions or visibility. A small example would be, let's say that you're a company and you want to issue your stock on a blockchain, right? As a company, you need to keep track of who your shareholders are, right? You need to know the identities of your shareholders. Maybe not in all cases, but in many cases. And so you would like the ability for a company to be able to issue that stock on a blockchain and basically have some kind of tracing dot on that asset as it moves around in the system, as people make secondary trades of the stock. And how could you do that so that that tracing dot remains visible to the company and still looks like any other transaction to everyone else? And the way that you do that is by using cryptographic techniques like zero-knowledge proofs in order to, without even the involvement of the company, like the company doesn't need to stick itself in any other secondary transaction, they can happen independent of the company. Zero-knowledge proofs will guarantee that this policy that the company put on this asset will remain true, that every secondary trade still remains visible to the company. And that's just one example. You can take that further, where anyone issuing an asset in the system should be able to specify some policies. And regulators are just a special case. Regulators require, say, that, regulators may want, in some jurisdictions, to have a backdoor visibility in all transactions, and that would be a special case. But they may require certain regulations, such as being an accredited investor in order to be able to participate in certain kinds of transactions, and that too could be enforced by a policy. So that's our approach. It's all about being able to be as flexible as possible in enforcing policies over confidential transactions, as well as auditability, which is the ability to demonstrate to someone after the fact something about your transactions. So let's say you're a bank and you're transacting over a blockchain and you want to prove to a regulator or even a consumer that you're solvent. Say you're a hedge fund and you want to prove that demonstrate somehow that you're not running a Ponzi scheme, that you're not embezzling money, right? A lot of finance now is run in an extraordinarily opaque way, and transparency is one of the hallmarks of blockchains. Like, privacy is maybe a requirement, but the whole point of a blockchain is transparency in some sense.
So Ben kind of emphasized that the whole thing that brings out consensus in the blockchain is the transparent aspect, and how they're working on about, like, and correct me if I'm wrong, letting the regulators basically set the rules and letting the users verify that, prove that they've been following the rules. Whereas Guy and Enigma, I think, have been much more focused on creating data marketplace on the other side, meaning allowing people not to have to share openly or keep track of the data, i.e. They have a partnership with Ocean Demi that was here in the previous panel.
Well, what's
I'm
the question?
setting you up,
Sure. Yeah, I guess again, we still believe very much in both in DeFi and in an ecosystem where people can develop their own, developers can develop applications that actually allow people to control their own data. That's kind of been our motive since day one. Generally speaking, I don't know. I mean, I can go on and on. Any specific question that would be interesting to talk about this?
Okay, let's go. How about that partnership? I think out of all three of you guys, I think you guys are the only one that have an active tooling system for secret contract out there and playing around with users. And can you talk about that deployment and how hard in general, because I think all of you, your projects tackle the same issues of developing dev tools and tooling specifically, so people don't have to be bothered with all the cryptography that's behind that and just write out whatever it is they want to use the blockchain for.
Sure. That is one of our biggest focuses. How can we actually make privacy tech usable in a blockchain context? So specifically, if I'm a smart contract developer, first step is, there's a lot of tooling out there to try to help you write secure smart contracts so that you don't blow things up. But that's one aspect. Now if you add another layer that actually allows you to encrypt the underlying data that flows through the network that people are computing over. How do you actually enable developers to do it without actually understanding the underlying cryptography? And even if they, and even beyond that, how do you make sure that they don't do stupid mistakes that eventually completely break privacy? I don't think there's a clear-cut answer to that. The best general approach that we've been taking is we put developers in the room who understands the privacy tech, developers in the room who are more like users, who are actually developing these like secret contracts and decentralized applications, and product people who are generally not technical, just know the space. And we kind of think together about what is an acceptable developer experience that we can create, but at the same time without actually making it so extremely, I guess, dumbed down that it doesn't provide any kind of privacy benefits. It's a tricky question. I think we're doing a better job than most in it, but it is a completely unsolved area. And I think if you ask most projects in the space, that is the hardest problem. I mean, even if you look at Zcash, right? Zcash, the technology is generally sound, putting aside what Ariel found a while ago, but the technology seems to be sound. But even when you make, just from a usability perspective, even when you make almost a trivial extension to allow moving from shielded and unshielded transactions so that it's easier to onboard people, like even that led to serious de-anonymization. So it's a really hard problem.
You guys know. There's like 3. Yeah. Now we just pick up.
Hello? Yeah, so making our product extensible and usable for developers is a big challenge. We just had a hackathon. Is Omri still there?
Last weekend.
Yeah, it was last weekend, and it was challenging because our code is all written in like hardcore C++, and go figure, and extending it's not easy. But we're now starting to work on something we call confidential assets, which is actually a way to issue additional kinds of tokens on our blockchain with the same privacy and scalability properties, and also defining potentially certain rules for them, similar to what Ben was talking about, like enforcing, when a share is moved between the two accounts, just make sure that they all are KYC and accredited, and then total number of shareholders doesn't cross a certain threshold. So once we have that, it will be easier. So I think in general, layer 1 protocols are, it's harder to provide tooling because there's not much you can build on top. You just need to build some extensions so people can build apps. And again, for us, it is a challenge.
So
Yeah.
he set it up.
Sure. I think that Alex and Guy have already answered quite well, but it's all about user layers, right? For developers, the user layer is the API, and for users, it's the user interface. So when you build a product, it abstracts away all the details of how the product is built, and it should explain to users clearly the features that they want. If you're advertising to someone the ability to transact confidentially, then you tell them what it does, and they should be able to use it in an intuitive way. And the complexity all goes into being able to clearly explain to people what exactly is this product that you're giving them. So giving a layer 1 blockchain to developers to build things on top of is the same. You need to have clear APIs that explain to the developer what it is that they're using. If it's a cryptography library API and you're implementing a zero-knowledge proof, then you should explain this API function allows you to have, some statement that you're proving. It has some inputs and it has some outputs, and you're not revealing any of the details. So in terms of what our focus are in terms of developer tools is, making it easy for people to write applications on top of a layer 1 blockchain that provides confidential transactions, and as I was talking about before, the ability to put policies on confidential transactions, and then allow a developer to easily, through clearly written APIs, build a peer-to-peer lending application. or build a secondary trading market application, or build an investment fund application. And it's all about just making it clear to the user.
So now I'm going to go completely anti-shill and tell you that most of what we were talking about, scalable and privacy, they have a trade-off, and it's a big fucking trade-off, meaning the computational resources needed for every one of these techniques is just as big and cumbersome as some proof of work. And the big question in all these three networks that you guys still probably have to answer for is what is the economic cost for all the stakeholders, considering what is needed from them, how much of that is going to be on-chain, and how much of that is dependent on off-chain computation that combines together with that network's economics.
So for me, it's actually a pretty convenient question, because Mimblewimble actually provides this privacy without extra costs, and even it saves them costs in the size of the blockchain. So I cannot say our users have to pay additional computational costs for their privacy. So we're good at this, at this at least, although, as I mentioned, if we want to provide even better privacy, then there may be some cost in computation and blockchain scalability. I think, though, that when ZK Snark started, it was really very heavy computation, but in the recent year and a half, it was really improved very much. So I think it's getting better, and eventually it's all about trade-offs, right? You want to get really good privacy or really good something. You need to be ready to invest some resources into what you want.
So I think one of the unfortunate problems in this space is that we don't really do a good enough job at clearly separating out what we mean by cost and isolating the different components of cost, right? The size of data that is stored on the blockchain is one kind of cost, and who eats that cost? The amount of computation, well, there's computation to validate transactions in a blockchain, and there's computation to generate transactions, and those costs are eaten by different parties. And so if you're a validator of a blockchain, you're also looking at millions of transactions in the span of a short period of time, and your costs for a millisecond transaction, operation per transaction is going to be much more significant than a user who has to spend a millisecond to generate a transaction. So the first thing is to focus on what are actually the important costs, and what are the ways of reducing those, and how much they actually, in terms of economic impact, it depends on who it's affecting. So my view is that the computation required to generate transactions is not as important, right? If you're a user, you're not generating millions of transactions a second. If you're a blockchain miner or validator, then you're verifying millions of transactions per second. So we should put a lot of effort into trying to make that verification very efficient. And in fact, it already is very efficient for zero-knowledge proofs. Verification is not the expensive thing in zero-knowledge. It's generation of transactions. And we've put a lot of effort, as have others and academics as well, into making verification super fast, the ability to aggregate and batch together many verifications in the time or span it takes to do one. In terms of the size, that's not eaten by users. That has an impact on the people, again, who are running the blockchain. And one of the goals of decentralization is to make it as easy for as many people to participate in blockchain validation as possible, and to reduce the amount of storage that any of those validators need to have. And I wouldn't entangle the privacy solution with the solution for that. It's very nice to keep things modular so that your solutions don't have too many interdependencies. And so, for example, Mimblewimble has a lot of interdependency between how it represents confidential transactions and how it reduces the size of the blockchain. We reduce the size of the blockchain with accumulators completely independent from private transactions.
Actually, this was something that we had gone through as we evolved from, I guess, more of a research project into a company. So we started with purely cryptographic-based MPC, multi-party computation. And over time, we've seen that, for some specific use cases, people are willing to pay the cost. There is still an immense overhead for MPC, just like other cryptographic techniques, like zero-knowledge proofs. And so for some applications, it did make sense. But for the long tail of applications, which is what we care about, most of them, people are like, yeah, we like privacy, but we're not willing to pay like, 10x, 100x, 1000x cost in my, there are concrete ways to actually assess costs. Right now I'm reducing it to like eventually there's a cost of computation, network computation, all of that, you can translate that into money. And basically people were not willing to pay for that level of, for that cost. And so we actually moved to secure enclaves based solution that simulates MPC. And in that case, yes, there's stronger assumptions on the hardware, obviously, but it's something that many more people are willing to use, and the overhead is minimal, like maybe it's 20%, I don't know, something like that. It's not orders of magnitude. And so I think this is a very important discussion. I don't think there's a right silver bullet. I do, in my personal opinion, think that for the long tail, you probably want something that is something like secure enclaves where the cost is minimal, but you definitely want other more deeper technologies like zero-knowledge proofs, like cryptographic MPC for different types of use cases. I would give actually one example where we've seen that this actually makes a big difference. We just released an Ethereum mixer that is based on our network, on our MPC/secure enclave solution, and you can clearly see the difference, right? It requires half of the transactions. So zero-knowledge based like mixers on Ethereum require about 2n plus 1 number of transactions. In our case, it's only like 1 transactions and that's it. So it's much easier from a UX perspective. It's much cheaper. And even the on-chain verification, like when you verify the proof in zero-knowledge versus our case, then the gas cost and the gas difference is like, that's actually like an order of magnitude lower. So I'm not saying everyone should use what we build. What I am saying is I really think the use case and what the users want and the level of security and requirements that they have should be matched to the cost of running that application with privacy.